Okay, welcome to this week's JMARS demo session. I'm going to be talking about some of the research I do, not as a JMARS developer, but in some planetary science work, and how I've leveraged both Python and JMARS to facilitate some of my research. My topic, I'm looking at what are called doublet craters. This is an example of a pretty famous one on Mars. You can see that there's two craters that it's believed they happened simultaneously because they're produced by a binary asteroid system, two asteroids orbiting each other, which then impacted with the surface of Mars in this case. And they always produce a characteristic septum, or this kind of straight line between them. And then a lot of the ejecta gets thrown out laterally because when the two craters are created, they try to throw ejecta in every direction, but it runs into the ejecta from the other crater and squirts it out the sides. So this is the kind of thing I'm working with. I'm just going to get rid of windows as we go. I will tell you that counting craters on a surface of a planet, and I'm concerned with Ceres in the main belt of the asteroid belt, it's tedious and laborious work. I've spent a lot of time doing it. And then I spotted this paper just last year, this one here by Toyokawa et al., where they basically mapped the entire surface of Ceres. I think they mapped over almost 175,000 craters all the way down to 1 kilometer diameter. I'm like, ooh, that's cool. And then I found that they included in the publication a CSV file of all the craters that they had found. And it looks like this. It's just the diameter and then the latitude, longitude. It's the other way around. It's longitude, latitude, and diameter in just a CSV file. And it has many records, 175,000. So I'm like, boy, what can I do with this, right? So my idea was to write a Python program that would read this file in. It would filter down to only the craters I cared about, which were those between 3 and 15 kilometers in diameter. And then it would go through all those remaining craters, match them up, and see which ones actually kind of overlapped a little bit, because then that could show evidence for a clear doublet. So my program does all that, and then it spits out all this data into a few files. The first thing it writes out, I'm going to close this down, is basically all the craters I was interested in. I think it turned out to be a little over 8,000, something like that. 8,800, almost 9,000. And it just has some information, like my program put out these headers. So it's, a label, which is just a unique number. I can talk about that crater, its longitude, its latitude, and its diameter. It's, in this case, it's radius in meters. Now that file is all fine, but what's really cool is because I formatted it with this header, it actually tells JMARS how to load it into the custom shape layer, which we've talked about previously about JMARS a lot. We talk about it a lot. And here is that layer. There they are, all 8,800 craters between 60 degrees north and 60 degrees south, and all the way around the center of the body. And now they're mine. I have them. I can see them. I can look them up. So that's useful. But my program also spit out another CSV file with better useful information for me. And this is actually writing out some specific shapefile entities. Gosh, Scott, is this the CSV version of what shapes look like for ArcGIS? Is that right?
It's a CSV file that can be used in a lot of different GIS tools. Yes.
Oh, okay. So anyway, I'm just creating for every crater pair that I thought was interesting, that my code found interesting. I'm creating a single entity, a single shape, which it's still hard to see what's going on here, but I can tell you, I've got it right here. Here it is. here's the actual, okay, that's not readable. So we're going to zoom in. And so wherever there's a pair of craters that overlap, it shows, like right here, a line from the center of one crater to the other, and it actually gives me the two crater numbers from my original crater table. So I know this is crater number 717, and this was 2539. And that's useful for, referring back to those craters later if I want to talk about them in any specific detail. So this is mildly.
So Paul, there seem to be a number of craters on the screen that overlap but don't have those kind of lines. So
yes,
you're filtering other things out as well.
I am. If the craters are too different in size, they have to be within. I'm just guessing because I don't have the code in front of me, but I think it can be no bigger than a 50% difference in size. So, like these two here didn't get picked. And these two here, even though they're close, they're the same size, they could be part of a doublet. There's no way to get that septum or the ejectolobes that really tells us for sure we've got a doublet, and it's not useful to me for what I'm doing to identify doublet craters that might be, so anyway, so that's a good question, and I just didn't want to go into that much detail, but thank you, good question. So, but we're going to do something else. So if you open up the layer, the crater pairs layer, hello, you get a table, of course, of all of the shapes that you're looking at. I've got to make it a little bigger, and don't need all this stuff up here. So all of the craters are in here, and I think they're currently sorted. How do I remove sort? I think that removed it. So this is in the order they originally appeared. But I also have all these extra columns that I created. And my code now produces those columns as well, which is really cool, because this is where I walk through. Here, let's just go look at the very first one. I can say center on that feature. So if we look here, that's the two craters right there. I'm going to just jump one more level. So this allows me to go through one crater at a time. Yeah, there's about 800 of them in here, and say, is that a doublet crater? Now, I'm getting really good at this. I can tell right away it's too eroded. I'm amazed they even found some of these craters. These guys really found very faint craters. Stu Robbins would be proud of these guys. So I can come over here right away and say, it's just too eroded, and I can check the box, right, in my too eroded column, and I move on to the next crater, and I say center on that one. Well, there we go. Oh, here's another couple of craters. Yeah, too eroded. You get the idea. And I have several different criteria by which I look at craters. Is the erosion different? Like one's really fresh and the other one's all worn out. Well, then they're not the same age. Or one is superposed over the other, where it's like clearly the one crater came in later and obliterated part of the first one, et cetera, et cetera. And I also have the ability in my final column to say, yeah, I think that's a doublet. So in fact, let's go look at this one. Okay. And it might not be obvious looking here. In fact, I find that having the crater ring and all the other stuff can sometimes make it harder to see what's going on. I'm even going to get rid of that. And this one looks like it has a septum. I actually used this one in some previous research. This was within my original study area, which was much smaller. And I did count this as a likely doublet. But another way to kind of examine craters in this case is to bring up our 3D layer, which is different from our 3D viewer that shows the whole body. So the 3D layer basically takes the current main screen and tosses it into a window where we can look at it in 3D. Now, right now, I can't see any difference, so I'm going to go over here and say, use the full range of values. And on top of that, let's exaggerate it at least double. Now when we look here, aha, see, and this is deeper than, I'm sure this is exaggerated, but this helps me to be able to determine, are they about the same shape? Is their depth to diameter profile equivalent? because we assume that these two impactors, if they were part of a binary, impacted at the same velocity, okay, or pretty darn close to the same velocity. So that's something I look at. There's a lot of morphological things that are important to me. And I'm not entirely convinced on this particular one, if that's truly a septum between the two craters. It is possible that this one came in a little later and caused some of this slumping of that septum wall, or the crater rim wall into the crater. But anyway, the whole point is, it's not whether I'm right or wrong about this crater. It's what tools does JMARS give me in combination with some opportunistic Python code that processes a lot of the data. Because the last thing I wanted to do was come up and work on this big map, with all of these craters, right? I mean, and have to go through manually and look for doublets, going through thousands and thousands of craters. So that's it. That's basically how I can pull these things in. The one other thing that is kind of useful, I can come over here and sort on these columns. So if I sort on doublet, sort on doublet, one more, it brings all the ones marked as doublet to the top. So I think there's I got around 20 of them. So this makes it easy for me then to easily get a hold of the data for these craters, because I've got the crater numbers. I can go make a table, for a poster. In fact, I'm getting a poster at LPSC in just a couple of weeks. So that's why I'm right in the middle of this mess, and made a good example for a demo. So I think that's it. Any questions, any things you think I left out, or you want me to go deeper?
I think that was a great presentation, Paul.
What was the time on?
I didn't start at the very beginning, but 11 minutes is what I see right now. So it's right in that time. So definitely in the 10 to 15 minute time frame. Cool. So this is more of a doublet crater question than a JMARS question, but yeah, is the reason that you expect they need to be the same size, is that because the concept of they're orbiting each other, if they were too disparate in size, they would just, one would get sucked into the other one? Is that the it's certainly there are binary asteroids that have a wide separation, but they also have one body is much bigger than the other. I mean, that was true of Didymos for the DART mission. Sure, there was a big disparity in the sizes. The real problem is that if they come in together, the larger crater usually is expected by people who work on this and have been working on it longer than me. It will obliterate any evidence of the smaller crater, right? Because they're still somewhat close. And we do find some craters that we refer to as a peanut doublet, where it's more like one elongated crater, but there can be some hints that it's actually, that the rims, that the single rim is really made up of the rims of two different ones. But again, we just expect that a really small body would be kind of like lost in the noise of the big one.
It seems like using the 3D layer there, that if you had a different angle, if the two, when you actually exaggerate it like that, and you can look at the the cup shape, if they weren't at the exact same angle, you can probably throw it out.
And that's a really good point. That's something I've been looking at doing, is trying to establish on a crater what's the, and keeping in mind that unless an impactor is coming in like below 30 degrees above horizontal, and that's not the right number, but it's low. It has to be a really low incidence angle to produce an elliptical crater. If it's 35, 40 degrees or anywhere up to vertical, it produces a perfect circle if it's, if it's coming in fast enough. So but you still do get some, if you want to call it upstream, there'll be more excavation of ejecta into the downrange edge of the crater if it's coming in an angle. And I was hoping that was something I could use to distinguish in a final analysis. And we did find some examples on the moon where what looked like a doublet crater probably wasn't, for the very reason you're saying. Like when you look at the profile from the side, it seemed pretty clear that they weren't made by things coming in at the same angle. So, but I haven't had much luck actually using it or finding a way to quantify how to prove it. It's more a subjective judgment, just eyeballing it. So. See you, John. There he goes, ladies and gentlemen, the John Hill.